All right, so section 8 is on average rates of change and instantaneous rates of change. We're also going to do a little something which is approximating the area under a curve. Okay, so it says there are 2 classic problems on every AP exam and in every calculus class. Okay, these two types of problems for years and years and years, people that were researching calculus had no idea that they were even related. Okay, but they ended up being the opposite of each other. So one is finding the tangent line approximation, and one is finding the area under a curve. So we'll talk throughout the year about how those two things are related by words like derivative and antiderivative, or you might hear me talk about integrals as well. All right, so the first classic problem said something like find the equation of the tangent line to y equals x squared at p at the point P, which is 2, 4. So here's what I'm asking for you guys to do. So basically you have y equals x squared. And we know that at point 2 we have the point, or at x equals 2 we have the point 2, 4. Okay, so when you guys were in geometry, you use the word tangent all the time. Okay, I always say tangent touches, secant slices. So in geometry, you guys had circles, and you would talk about a tangent line to a circle. And it would just barely touch. Okay, that's the same thing that's happening here. We have a line that's just going to barely touch the curve. It's not going to intersect the curve. It's not going to be like a secant, which slices through. However, if you do have a curve, you know, like you have a polynomial like this, if I draw maybe a tangent, I don't know, where's a good place to draw it? I don't know where a good place to draw it is. Maybe like right here. I draw a tangent line there. Then yes, if I draw this line and I extend it, it actually does cross the curve. So it can cross in other locations, but if I zoom in that particular area, it looks just like a tangent for a circle. It looks like a line that just barely touches. Do you guys know what I'm saying? Okay, so that's why we call it a tangent. All right, so basically I'm asking you to find this tangent line. Okay, and the way that we're going to do it is we're going to use several secant lines to find it. We're going to connect 2 endpoints and get a secant. Okay, so we're going to start out with like 2.5. So if I zoom in just on that portion of the curve, let me really zoom in. If I zoom in at 2, 4, and I talk about 2.5, 6.25, that's what you get when you do 2.5 squared, right? Y equals x squared. And I connect them, that's called a secant line. Okay, does that make sense? So we have the secant line, and we're going to take the secant line, and we're going to slide them together like a limit. So we're going to make the secant line smaller and smaller and smaller until it looks like there's just one single point. Does that make sense? That's what we're going to do today. Okay, so calculus the entire year is related to limits, which makes some of you guys sweat a little bit because limits are hard, right? We don't always, like, you don't always see like limit written out. So sometimes we're going to have limits and you're not even going to realize you're using them. Okay, so anyway, so let's find the y values. So if I have 2.5 and I square it, right, I get 6.25. If I have 2.1 and I square it, didn't even do that, what do we get? 4.41. If I do 2.01 and I square it, we get 4.0401, is that right? The next one should be 4.004001, and the last one should be 4.0004001. Okay. Okay, we're definitely getting closer to the point 2, 4. This is not what we're caring about, not necessarily this little t-table. What we're worrying about is the slope. Okay, so we're going to look at this next little chart. And it says the x value at point Q was 2.5. Remember, that was the point 2.5, 6.25. Huh? I missed a 0? Oh, man. All right, Audrey gets a point. Audrey, write your name on the board so I don't forget. Oh, Maddie gets it? I don't know. All right, so here's our point. So we have this point and we have the point 2, 4. And we're going to find the slope between them. So we know how to find the slope between 2 points. This is not hard. Right? You can write it out and you can say, okay, I'm going to have 6.25 minus 4 all over 4 minus 2. Right? And then you can find it. So if you put that into your calculator, solve it out, you end up getting 4.5. So you can do this for each one. I'll just tell you what they are because I memorized them. They're not hard to memorize. I'll show you the trick. All right, so the next one. So if I have 2.1, that was the point 2.1, 4.41. So when I find the slope between 2, 4 and 2.1, 4.41, right, what I'm doing is 4.41 minus 4 all over 2.1 minus 2. And for this one, I end up getting 4.1. Yes?
The bottom should be 2.5 minus.
Oh, yeah, 2.5 minus, thank you. 2.5 minus 2. Yeah, I'm just really, you're racking up the bonus points today. So 2.5 minus 2 there.
Okay.
All right, so, and you continue this pattern. So you're continuing the pattern, you're still doing everything. This one ends up being 4.01, 4.001, 4.0001. Okay. Very easy. Did you see how I memorized all those numbers? What did I just do? To get the slope, I just added 2. You guys see it? How it's related? All right, and the reason that works is because really if you take any point along the curve, y equals x squared, right? Any point is in the form x comma x squared. So if I set up the slope, it's going to be x squared minus 4 all over x minus 2. Well, what does that factor out and reduce down to? Just x plus 2. So that's how I knew it was always 2 more than the slope. Does that make sense? They don't all have these fancy tricks. Sometimes you really just have to do it by hand. It takes a while. All right, it's not hard though. You guys can all find the points. You can find the slopes, right? Okay. So it says, what do you predict the slope is? So what's our slope getting closer and closer to? 4. So our slope is going to be 4. So then it says, use this to find the equation of the tangent line of y equals x squared at 2 comma 4. So we have a point, right, 2 comma 4, and we have the slope, which is m equals 4. So can you write the equation of the line? Yep. So you're going to have y minus 4 equals m times x minus 2, or 4 times x minus 2. All right, that's your answer. Leave it like that. I don't know how many times I say this. I say leave it like that, because on the AP test, if you go further and you simplify and then maybe you make a mistake when you're adding the 4 over, you just accidentally subtract it over, you're in a rush, right? You don't get any points for that then. If you get it wrong, you miss all your points. So don't do that. Just leave it. All right. So same thing on this. So we have y equals the square root of x now. So if we have the square root of x, and we want to talk about the point 4 comma 2. So it says graph the secant line passing through 4 comma 2, so point P, and point Q, which is going to be, sorry, I have to sneeze. Sorry, 3 comma root 3, right? That's going to be the first point. And the other one's going to be 5 comma root 5. So 3 comma root 3, so somewhere around here. So that's our first Q. So when we connect those points, we just get a little tangent line. And then the other one, 5 comma root 5, that can be the other Q. Maybe I'll call it Q1 and Q2. Will be tricky. All right, so when we connect those, we get another secant line. 3 comma, yeah, it should be before, thank you. I was wondering, I was like, I could have swore that was, okay, yeah. I can't see my little numbers, I'm blind. So here's my 3 comma root 3. So that's going to be Q1. And then Q2. So Q2 was the 5 comma root 5. All right, so we get 2 secant lines. So if I really exaggerate this curve, you'll definitely be able to see what's happening. So if we're connecting here, super steep, right? But if I connect here, not so steep. But the equation of the tangent line, right, that slope, kind of in between. Do you get it? So one is super steep, one is not as steep. The tangent line one is going to be kind of directly in between. So what do you think we're going to do? So what's a good way to find an approximation for the tangent line one? Yeah, Elena. I can't see my numbers, so I have no idea. Mine are like all blurry on my screen. So is it here? Yeah. Okay, thank you. So that's Q2. All right, so anyway, so a good way to find this approximation would be to find the first secant line, find its slope, find the second secant line, its slope, and then do what? Average the two, right? Because the one that we're trying to find is kind of in between the steepness. Okay, so we're going to do that. So our first slope, so I'll say the slope of P and Q1. So I'll write it as PQ1. Or you could just write the slope between those x equals 3 and x equals 4. All right, so if I'm doing that one, it's going to be 2 minus root 3 all over 4 minus 3. So we get 2 minus root 3. All right, if you wanted to know a decimal approximation, just put it into your calculator real quickly. Root 3 is around like 1.7 something. So we get 0.268. All right, and then if I want to find the other one, it's going to be root 5 minus 2 all over 5 minus 4. So it ends up being root 5 minus 2. So that's going to be approximately 0.236. I guess it's part B. I found the slope of each line. That's on the other page. All right, so it says use the results to estimate the slope at 4, 2. So how could we improve it? We could add those two things together and we could find the average. So our average would be the first number plus the second number and divide by 2. So if I actually wrote out with the roots, it'd be 2 minus root 3 plus root 5 minus 2. All divided by 2. And the 2's end up canceling. So we get root 5 minus root 3 all over 2. So that would be the average, which is approximately 0.252. Okay, so that ends up being pretty close. The actual value, if you actually find it with calculus later on, it's going to be 1/4. So really, really close, actually. All right, so what are ways we could improve our approximation? What if we picked points that were even closer, right? What if we picked like 2.5, or not 2.5, 4.5 and 3.5 and got on each side, or 4.1 and 3.1, then we would be even closer, right? 3.9, I guess. All right, so next thing, so average rate of change. So this is not a hard concept. The average rate of change is actually a very important formula for the AP test, though. You need to know it. Okay. So the average rate of change is going to be f of b minus f of a all over b minus a. All it is the slope. Change in y over change in x. That's all it is. So in this one, so it says find the average rate of change of the function f of x equals x cubed minus x squared over the interval 1 to 2. So what I want you to do is I want you to take the endpoints, so between 1 and 2, and you connect them. So I have this little drawing here so you can see all we're finding is the slope between the endpoints. Okay. So if I find f of 2 minus f of 1 all over 2 minus 1, and I need to find what f of 2 is, f of 2 is going to be 2 cubed minus 2 squared. So 8 minus 4 is 4. And f of 1 ends up being 1 minus 1, which is 0. So I'm going to have 4 minus 0 all over 2 minus 1. So I end up getting 4. And you can count that, and that slope actually is 4. It doesn't really look like it's 4 because these ones go up by 1 unit. And then these ones go over, like 1 unit is really far. But it is 4. So we do your rise over run. Okay, so every time it says find the average rate of change, that is an easy point on the AP Calc test. You just need to do that. F of b minus f of a all over b minus a. Okay, but there's other things that involve the word average, and people get confused. They just don't know the formula. Okay, so don't get confused. Average rate of change is a slope. So it says if you wanted to find the rate of change at exactly 1.5, so if we wanted to find right there in the tangent line, we could use limits and keep getting closer and closer to 1.5 on both sides. So you could do like 1.4 and 1.6, 1.49 and 1.51, right? And you get closer and closer and closer. So when you do that, when you take the limit, it's called the instantaneous rate of change. Okay, that's sometimes just called the slope at x equals 1.5. So let's do a simpler problem so you understand what I'm saying. So for this one, so it says compute the instantaneous rate of change for g of x equals x squared. So we're going back to a really simple function, just g of x equals x squared at the point 3. So we're trying to find the slope right there at that point. Okay. So what we do is if I zoom in, I pick 3, 9, but I also want to pick a point that's super close to it. Okay, so I'm using h, and h is a tiny little value, like 0.000001. Okay, so what I do is I have 3 plus h, so I'm slightly to the right of 3. In my function, right, I'm going to plug in 3 plus h into the function. What function am I using for this curve? F of x equals x squared, right? So that we're just going to have 3 plus h squared is going to be the y value. So you can write f of 3 plus h, or you can write 3 plus h squared. Right, we're just plugging into the function. So if I asked you to find the slope between those 2 points, you guys could do it, right? You would just say 3 plus h, let me write it out, f of 3 plus h minus f of 3 all over 3 plus h minus 3. So our function is x squared. So it's 3 plus h squared minus 9 all over 3 plus h minus 3, which ends up being h. Okay. And the way it's related to the limits is we're just going to make h get closer and closer and closer, just like we do with the table of values. So h, we could use 0.1, 0.01, 0.001, 0.0001, right? We're making h go to 0. So what we're going to write in front is the limit as h goes to 0. Okay. Would you be able to solve that limit problem? What would you do? Because you can't plug in h equals 0 right now, right? You get undefined. So what do we do? Not factor. Yeah, FOIL it, right? Expand it. So if you have 3 plus h times itself, if you need to write it off to the side, it's fine. I did when I was in AP Calc. I always had to write it off to the side. So we get 9 plus 6h plus h squared minus 9 all over h. And if you do this correctly, every single time you do these problems, all the things that are just plain numbers end up canceling. So see how my 9 and my minus 9 go away? That should always happen. You should now be able to divide by h. So when you divide by h, you get the limit as h goes to 0 of 6 plus h. So plug in h equals 0, and we get 6. So what we just found was the slope at that point that we wanted, 3, 9. Okay? So would you be able to write the equation of the tangent line then? Yeah, you have the point and you have the slope, so you could do that. So it says the slope at x equals 3 is m equals 6. So the equation of the tangent line is y minus 9 equals 6 times x minus 3. Done. Okay. I can't tell you how many times you're asked to write the equation of a tangent line on the AP test. There will be easier ways, but. All right, so the instantaneous rate of change of the function. So that's what I said we sometimes will just call slope. So it's the slope between x of f, or x comma f of x, and a point that's really super close to it, x plus h comma f of x plus h. But then we take the limit as h goes to 0. So it ends up being the slope at x, not x equals a, because I didn't put an a in there, just at x. So it's found by the limit as h goes to 0 of f of x plus h minus f of x all over x plus h minus x. It's the slope, right? So we can at least simplify that bottom. So it's going to be f of x plus h minus f of x all over h. Okay. So this one's telling us, so we're given the x value, in this case our t value. So when we set this up, we're going to say the limit as h goes to 0, and we're going to find f of 4 plus h minus f of 4 all over h. So we're trying to find that. So our function is 3t squared minus 2. So if I asked what is f of 7, every single person in this room would know how to find f of 7. You just plug in 7 into the function, right? You replace all of your t's with 7. So if I say f of 4 plus h, what you're doing is you're replacing all of your t's with 4 plus h. So you're going to have the limit as h goes to 0, and I'm going to do a big bracket minus another bracket. So that way I can see what each one is. So when I say f of 4 plus h, what I'm saying is 3 times 4 plus h squared minus 2, like that. And when I say f of 4, I'm just plugging in 4. So I have 3 times 4 squared minus 2. You see how I got those? And then we just simplify. So the simplifying is the hardest part, you know. But you should know how to do it. So we're going to have 3 times, if we FOIL out 4 plus h squared, it's not going to be 16 plus h squared. FOIL it out, you get 16 plus 8h plus h squared minus 2. And then we have minus, this is going to be 48 minus 2, so 46 all over h. We distribute the 3, so we get 48 plus 24h plus 3h squared minus 2 minus 46 all over h. If we did it correctly, all the things that have just plain numbers and no h's will go away. So we have 48 minus 2 minus 46. So we have the limit as h goes to 0 of 24h plus 3h squared, so it's going to be 24 plus 3h. So what's my slope? 24. Right, plug in the h goes to 0. So your equation of your tangent line is y minus, what did I get when I plugged in 4? What point was it? 4 comma 46, is that right? Yeah, 4 comma 46. So it's going to be y minus 46 equals 24 times x minus 4. That's your equation of your tangent line. I'll pause here so you guys can go on break. All right, so for this, so you have to do the limit as h goes to 0, and I told you that you're going to actually plug in x plus h everywhere there's an x. So this is the first big bracket. That is the f of x plus h. And then you're going to have minus f of x. So f of x is just 2x squared minus 3x. Definitely put brackets around, though, because a lot of people will forget to distribute the negative in. Okay, so put brackets or parentheses there. All right, so as we FOIL out the x plus h part, we're going to have 2, and then we're going to have x squared plus 2xh plus h squared. And then minus 3x minus 3h. That is the first bracket. And then minus 2x squared plus 3x when we distribute the negative. So we get the limit as h goes to 0. We're going to distribute the 2 in. So we're going to have 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. All right, and if you did this correctly, a lot of things will cancel. So in our case, we have negative 3x and positive 3x. We have 2x squared and negative 2x squared. Okay? So now the h goes into everything. It should go into everything. If you have just a number there, then you've done something wrong. Okay? So we get limit as h goes to 0. We're going to have 4x plus 2h minus 3. Now as h goes to 0, we end up getting 4x minus 3. Okay, so that's our slope. Okay, so that's the slope for any x value. So we've left the x in our problem throughout the problem. Okay, so if I said, what is the slope at an x value of 0? What would the slope be? It would be negative 3, right? So you would never leave that x in as you did like an equation of a tangent line. So if I said, okay, do this for part A, now find the equation of the line, the tangent line at x equals 1. Then you would plug in 1 to find what your y value is, so negative 1. And then you'd say, okay, my m is going to be 4 times 1 minus 3, it would be 1. Okay, so you would then use those different things. You don't leave x where your slope is, like in your formula. So you would find the number. Okay, so it says occasionally you will see a question that asks for a normal line. Okay, so what a normal line is, it's the line that's perpendicular to the tangent line. So it's kind of weird. So if you have some kind of curve and here's your tangent line, the normal line ends up going like this. So they're perpendicular to each other. So if you get a tangent slope of like 2/3, then what's the normal slope going to be? Negative 3/2. Does that make sense? So you just do your opposite reciprocal. So you're going to do the same process that you did to find the tangent line, and then you're just going to take that slope and do the opposite reciprocal. So we're going to do it again. So we have the limit as h goes to 0. We were given our x equals 4 this time, so we can do f of 4 plus h minus f of 4 all over h. So we have the limit as h goes to 0. We have 2 minus 4 plus h squared. So I'm going to put that in my brackets. That's the f of 4 plus h. Minus f of 4 is going to be 2 minus 4 squared. Oops, not 2, h. All right, so we get the limit as h goes to 0. We have 2 minus, if we FOIL it out, we get 16 plus 8h plus h squared. Minus 2 minus 4 squared is 2 minus 16, so negative 14. All over h. Continue to simplify. This is why I always laugh when like my calc students say, oh, quadratic formula. I'm like, quadratic formula is like the least of your concerns in calculus. There's a lot of problems that take a long time. All right, so we have 2 minus 16 minus 8h minus h squared plus 14. So see how our numbers go away. 2 minus 16 plus 14. Negative 14 plus 14. So we get the limit as h goes to 0. We have negative 8 minus h. So we get negative 8. Okay, that's our slope. So for the normal line, its slope is going to be what? 1/8, right? So the normal slope is important. You'll deal with the normal slope a lot of times in physics. So if you talk about like pushing a box up a hill or something, you would want to find like the weight that the box is like pushing on a ramp. Have you guys done those ramp problems in pre-calc? Like this is the normal force. Okay, so that's the force that's perpendicular to the plane. Okay, so that's why it's important. And you can kind of feel it when you're like walking up a hill. Like you can kind of feel where your force is going. Like, I don't know. Try that sometime. Walk up a hill and feel the normal force. Okay, so anyway, we have 1/8. So if I want to find the equation of the normal line, again, I have 4 comma, we have negative 14 was the point. So the equation of the normal line would be y plus 14 equals 1/8 times x minus 4. That's our answer. Okay? All right, so one last topic, and it's a pretty easy one. So this is finding the area under a curve. Okay, so we're not actually going to find the area, but we're going to learn approximation methods today. So this is kind of a preview of definitely second semester. We do this all the time. Okay, so there's another common situation in calculus is the area problem. So for instance, if we wanted to approximate the area under the curve y equals x squared between 1 and 3, right, we're talking about, oops, this area right here. Okay? Okay, and we could try to approximate the area in lots of different ways. So you guys can look up here. You don't have to draw this. But you could say, oh, it kind of looks almost like a triangle. So maybe I could find the area of this triangle and add to this rectangle. Right, and you get a pretty close approximation. Okay, but in calculus, we're not going to use triangles. Instead, we are going to use rectangles. Okay? So in order to do this, I'm going to choose several x values between these points. So to keep things simple for this very first example, I'm going to use 1, 1.5, 2, and 2.5, the partitions that you already have. Okay, we call those partitions. So if I want an underestimate, I don't want to fill the entire space. I'm going to be under what the actual area is. So in order to do that, I'm going to use what I call left-hand endpoints. So I'm going to just take that left endpoint, and I'm going to go straight over. And I'm creating rectangles. You see them? Okay, and these rectangles have area, and when I add them together, it ends up being less than what the actual area under this curve is. Okay? So I have 4 rectangles. If I talk about the heights for these 4 rectangles, so the height here, here, and here, and here, and I talk about the width of the rectangle, right? If I talk about the height, what I'm using is some value that is along the curve. So for this first height, I had at 1. What is the height for that one? What's our curve? Y equals x squared, right? It's 1. That point is 1, 1. So the height of that first rectangle is just 1. What is the height of the second rectangle? 2.25. Good, because you're taking 1.5 and you're squaring it, right? That point on the left hand is 1.5, 2.25. Right, how about this next one? 4, and then the last one? 6.25. Good, because it's 2.5 squared. So if I want to find my of course the under's on the other page, underestimate, I have the width of the first rectangle, which is 0.5 for the width, right? All of them are 0.5 actually, times the height. So 0.5 times 1. So I'm going to write 0.5 times f of 1. 0.5 times f of 1 plus 0.5 times f of 1.5 plus 0.5 times f of 2. You don't have to write the f's. I'm just doing it for your notes, really. Okay. Do you see how we can pull the 0.5 out? They all have a 0.5. Okay, so f of 1 was 1, f of 1.5 was 2.25, f of 2 was 4, and f of 2.5 was 6.25. All right, so if you find that, 10.25 plus 3.25, 13.5 times 0.5, so we end up getting 6.75. Okay, that's our underestimate. Okay, our overestimate, so same idea, but now when we draw our rectangles, we're going to go over the curve. Okay, so instead of using what I just called left endpoints, so starting on the left corner and going straight over, I'm going to use what I call right endpoints. So I'm going to start here and I'm going to go straight over. I'm going to start here and go straight over. Here and straight over. And here and straight over. So now the heights are a little bit different. Okay, the widths are still 0.5, but now this first height was going to be when I plugged in 3 and I squared it, I got 9. This one's going to be 6.25. This one's 4. And this one's 2.25. Everything gets like shifted over a little bit. Does that make sense? Okay, so the overestimate ends up being 0.5 times 2.25 plus 0.5 times 4 plus 0.5 times 6.25 plus 0.5 times 9. Okay, so that one ends up being 10.75. Okay, so if you were making a guess on the true area, what would you do now with these values? Right, you just take the average. So you're going to take the average. So you're going to have, what was it, 10.75 plus 6.75 and divide by 2, and what do we get? 8.75. Oops, I'm going to divide by 2. All right, so 8.75. Okay, so if I actually use calculus and I find what this answer is, the answer is actually like 8.6 repeating, 8 2/3. So if I did all the calc steps and found the answer, it would be 8 2/3. Pretty darn close, right? 8.66666, right? Really close to 8.75. This was only using 4 rectangles. So what do you think happens if you use even more rectangles? Yeah, you get even closer, because basically, as you have your curve, right, if you're using big rectangles, you could be pretty far off, right? You have lots of like big triangular type of regions where we don't have any area. But if you use little tiny rectangles, right, you're filling almost the entire space. Does that make sense? So if you use even more rectangles, like if I used 100, 1,000, and so on, right, it would be even closer. Okay. So what we're going to do in calculus is we're going to learn to take n, the number of rectangles, to go to infinity. Right, we're going to do a limit. So would be closer. You guys are like, woo, that's exciting. All right, so the last one, yeah. All right, so any questions on any of that?